Hello, I'm Shea Grady, and I am an undergraduate student at San Francisco State University's Estuary and Ocean Science Center in Tiburon. I am pursuing a master's degree in interdisciplinary marine and estuarine sciences and a certificate in data science. In terms of my research interests, I'm curious about shallow estuarine habitats and how they support eelgrass beds, tidal marshes, and photosynthetic microbes that may buffer local acidity spikes, which result from human activities, climate change, and urbanization of watersheds. For example, submerged plants and other autotrophs in shallow estuarine habitats can uptake acidity drivers, such as CO2, for photosynthesis and produce dissolved oxygen and higher pH water as byproduct. Currently, I am investigating San Francisco Bay to locate some of its own acid buffering shallow estuarine habitats. Additional to surveying for acid buffering potential in shallow estuarine habitats, I would like to build a more robust understanding of organic alkalinity, an important constituent of water's buffering capacity. In offshore settings, organic alkalinity is assumed to be negligible. However, unlike offshore settings, estuaries typically receive higher inputs of dissolved organic matter, a chief contributor to organic alkalinity. We need an accurate measure of organic alkalinity to have a comprehensive understanding of estuarine buffering capacities. To begin a holistic understanding of the acid buffering capacity in these shallow habitats, I'm investigating 4 unique estuarine habitats within San Francisco Bay: the Estuary and Ocean Science Center's monitoring station, a deep main channel habitat; Richardson Bay, a shallow embayment with extensive eelgrass population; Chinacamp State Park, a shallow mudflat with minimal aquatic plants; and Gallinas Creek, a tidal creek bordered by intertidal marsh. Specifically, I'm evaluating each of these sites for their levels of buffering potential and organic alkalinity over seasonal timeframes, tidal cycles, and across spatial gradients. Global climate change, increasing human population growth, and habitat fragmentation are only a few factors adding to the vulnerability of urbanized estuaries, such as San Francisco Bay, which are predisposed to spikes in acidity from coastal upwelling and eutrophication, in addition to growing ocean acidification. Determining levels of buffering potential and organic alkalinity is important to developing robust management and protection of estuaries. By funding my own academic pursuits, ARCS is not only supporting my own curiosity in contributing to basic science, but also to the future of Earth's estuaries.